Malawi Fish Farm. Project Concept. Gulf Technology Systems. Global food security industry. Global population is expected to reach 8 billion by 2023 and will cross the 10 billion benchmark by 2057. The challenge is not only to feed all of us, but to do so with high-protein foods and at an affordable price. Aquaculture represents one of the most important sectors able and expected to meet the increasing demand. Who we are and what we do. GTS works for sustainable industry development and farming globally. We work actively with our partners and participate in all processes from design to market. Developing new and interesting jobs, increasing food production while minimizing environmental footprint. GTS specializing in food production, fish farms, agriculture farms, and meat production farms. We provide turnkey projects with trained management and staff. We design, construct, manufacture and assemble the farms, and provide training/supervision for the operators. Some of our fish farming technology is patented and unique in terms of water treatment, energy saving and efficiency. We provide engineering, project management and monitoring, energy solutions, and other various customized equipment for the projects. Once established, each project is supported with supply chains and resources, as well as markets, sales and distribution channels. Natural fish supply on the decline. Pollution and climate changes. Increasing pollution at sea threaten fish and marine animals all over the world. The oceans are full of plastic and microplastic particles and are experiencing constant pollution events, endangering marine life and marine food supply. Unregulated commercial fishing. Access fishing has reduced natural fish population globally, making fishing not only more expensive, but also endangering the supply altogether. Offshore versus inland systems. Inland system. Recirculation of water. Environmental control. High intensity. Low number of personnel. Offshore system. Flouting cages in the sea. Natural environment. Up to 200 ton per cage. Relative high personnel demand. Relevant species. Sea bream. Cobia. Orange spotted grouper. Sea bass. Atlantic salmon. White shrimp. Yellowtail amberjack. Barramundi. Blue mussel. Our plan for Malawi Fish Farm. Fresh and healthy seafood production and processing. Export-oriented production dictates high-quality process and final product. Supporting global food security needs. And reduce trade deficit by exporting locally produced goods. Labor-intensive, creating professional and labor-intense new jobs. Sustainable and forward-looking industry development. Minimal environmental footprint by recycling water, self-sufficient energy production, minimal supply chains and many other green technologies. Fresh produce for local markets support local food security. Eco-friendly minimal discharge. Water circulation. Fish farm is set up for minimal discharge. This means that approximately 95% of the water is recirculated and all mineral content is harvested. Local energy production. All the plant energy needs are provided locally, using PV panels on roofs and building sides. Storage battery systems ensure 24/7 energy supply. Command and control monitoring systems ensure low energy intake constantly. Compliance with international standards. Our fish farms meet the strictest environmental and sustainability requirements and are approved in USA and Israel. Layout example: 10,000 tons/year fish/seafood farm. Existing farm pictures. 800 tons/year fish farm with 2 modules, each module 400 tons. Israel. Assembly, welding and waterproof testing of tanks. Some of the water treatment equipment in the farm. Feed dispensers. Filling up grow-up tanks with clean and treated water. Biosecurity. Marine biology. Biosecurity is a key to successful fish farming. It is important that effort is made to ensure that no pathogens are introduced into the farm from outside by vehicles, visitors, staff, equipment. At the same time, no exchange of live biomass is allowed with the natural environment in order to protect it from foreign species invasion. Marine biologists are experts in this field and a necessity on larger farms to quality control all biological production phases and processes. Critical advanced technologies. Hatchery, feed factory, artificial intelligence management and system monitoring. Artificial intelligence used to monitor and manage all production staged. Artificial intelligence incorporated in the fish tanks and in all production stages and factories to ensure maximum production quality and quantity. Hatchery, production of fish fingerlings. Most fish farms import their fingerlings from separate professional hatcheries. We intend to grow our own fingerlings in situ, thus control the supply as well as the quality of final product. A novel automated fast cycle hatchery. This hatchery is a carefully managed and monitored environment, designated to support each stage of the egg laying, fertilizing, hatching, and the growing of fingerlings, resulting in multiplied production speed. Minimizing payload losses by optimizing environment conditions and minimizing risk factors. Feed factory. In order to supply daily consumption of feed, it is necessary to set up a separate feed factory. Black soldier fly larvae and mealworms factory. This protein and oil-rich food is idyllic for fish and fingerlings. Expedites growing time and provides nutrients for the fish, which goes on and translates to high-quality end products for human consumption. Larvae and worms are easy to grow and harvest. The feed factory promises perpetual daily supply of feed regardless of supply chains and markets. The larva is grown on detached and condensed beds. Both larva and beetle/fly are fed local organic materials, fish leftover, algae and other locally produced extracts. Normal feed sources are grain meal mixed with ocean-sourced protein. This expensive supply is obtained in markets and lays a heavy cost on the farm as well as on the oceans. By using self-grown larvae, our farm will support ocean ecology protection. System monitoring. Based on an array of sensors and managed by artificial intelligence, we can manage the farm automatically. The sensors monitor everything: environmental conditions in the water, temperature, currents, available nutrients, existence of pathogens, etc. Fish feeding, growth and density. Health condition and quality factors, such as fat levels in the fish meat. Identification of weak or ill individual fish and fishing them out. Artificial intelligence manages and commands the response to any planned stage or surprising situation that rises, keeping the fish at optimized condition at all times. Minimizing the risk of viral infections and the use of antibiotics or pesticides that can damage the final product quality. Upon the discovery of a wide unwanted condition, the artificial intelligence has the option to apply immediately one of several mechanisms: discard the biomass, change water temperature, inject the tank water with oxygen, etc., without the need for human interference. These pre-planned responses secure the safety and integrity of the whole farm. Monitoring and managing production this way allows us to mark final products as high-quality natural or organic, resulting in an efficient, streamlined production that is easy to monitor for quality assurance and manage marketing demands. Environmental conditioning. Many fish like salmon need to complete their natural life cycle in order to reach their spawning ponds upstream. Salmon in particular reaches maximum weight and size just before they run upstream. Our farm provides, per species, the idyllic conditions at every development stage to follow their natural instincts in order to reach maturity or reproduce, pending the harvest goal. Salmon ponds are shaped as an oval canal. The fish swim around constantly. Upon the growth stage, they will meet different environmental conditions. These conditions include water salinity, temperature and currents, obstacles, and slopes. Beluga and other caviar-producing sturgeons are large, solitude fish with affection for cool, shallow water. They are also provided with an environment that is conducive to the caviar making stage of life cycle and the leading stages. Processing and jobs. The 9,600 tons/year shrimp farm will process and ship to customers about 26,000 kilograms shrimp per day when fully expanded. Processing provides many new jobs and new opportunities for community development. This size farm will provide jobs to about 360 people in addition to extended effects. On average, one worker per 26 tons a year production capacity. Additional supportive factories and units. Processing factory. Producing a variety of cleaned or filleted fish and seafood for international markets. Local market can have fresh supply. Smoked fish catering to different market flavors. Caviar and shell food as well as other gastronome products. Spices and stock powders for the flavor industry. Packaging factory. All exported fish products are processed on site, canned or vacuum wrapped and frozen for shipping. Fish and shrimp hatchery. Fish feed larva factory. General costs. Cost about $1 million per 100 ton not including work and fish feed. Harvesting start between 12 to 18 months after first population depending on species. Cost $500,000 per cage not including work and fish feed. Markets. The final part of the farm project is marketing. We can secure both distribution channels and destination markets. This will be orchestrated together with the design of factories and products in order to match products with markets and flavors.